Hi, I'm an old guy and I do maths. Today we're looking at equating coefficients, and when people see this done and it's not explained to them that that's what's going on, this looks terribly confusing. Uh, it's um, it's a lot of numbers and letters, and it's a little difficult to see what's going on. So essentially what this is about is it's about making one function equal another. And usually the other function, the second function, has some pronumerals in it rather than it just being a straight out function, such as you see on the left here. So this is pretty typical of the sort of basic question that you get asked when you're asked to equate a coefficient. So let's see what we've got. 2x cubed minus 18x squared plus 54x minus 49, and we are to make this equal this, or this equal this. Take it as you will. We have to find out what a and b are. And you'll notice that this is in a different form to the function on the left, the expression on the left. So one of the first things that I would do, and in fact what you have to do because you can't do this any other way, is you've got to work out an expansion of this. And so that's noted here. We expand a into x minus 3 cubed plus b. And it's kind of a two-step process usually. The first thing I would do is I would expand this. There are various ways of expanding this. You can do it longhand. You can square this number, this expression here, and then multiply it again by x minus 3. You can use binomial theorem if you want to expand it. Probably the fastest way to expand it, other than just doing it longhand, is to use Pascal's triangle. Anyway, the result of the expansion of this expression in the brackets cubed is set out below here. X to the power of 3 minus 9x squared plus 27x minus 27. And we have to take account of a and b. So we haven't finished expanding this. When we finally expand it, what we get is ax cubed minus 9a. Every x gets multiplied by a. So 9ax squared plus 27ax minus 27a plus b. Now, the next step is simply how I do this. It's not usually the way in which it's done, but setting it out this way gives you a very clear path to solving for both a and b. And we only have to solve for a and b here. We'll actually solve for a in the first pass, but we'll go through the motions with the rest of the expression, and we'll just confirm twice that a actually has the value as stated. So here's how I set it out. Here's my original function, and here is the second function fully expanded. And what I've done is I've set this out in columns. So this is like going back to primary school with ones, tens, hundreds, and thousands. Anyway, so what we've got to make sure of is that we can make this equal this. That's the very first step. And if we're correct, if we've done everything correctly, then if we insert the solution for a here into this and into this, we will get this and this. So, first things first, we figure out the coefficient of x cubed. And the coefficient of x cubed is 2, and that must equal a, so a must equal 2. Now, confirming this, we have the coefficients of x squared, negative 18, and negative 9a, well, if we insert 2 here, we get negative 18, so 2 is confirmed as a, and the same is true here. So this is a very straightforward piece of work. So we've found a. What that's going to do is it's going to enable us to find b, because negative 49 has got to equal negative 27 times 2, which is what a is, plus b. And that we can solve down here. There's the setup for the equation. We put a into this and we get negative 49 equals negative 54 plus b. That is a b, one of my horrible b's. We already have the answer a. We know what that is. b is 5. We've simply solved this equation. And that, if we put that back into this, so if we put 2 here and we put 5 here, and we fully expand this, which I'm not going to do, but you may choose to, just to check my work, you will get this. And that is how you equate coefficients. That's the basic way in which you do it. Thanks very much for watching. I hope this was useful. If it was, please like the video and subscribe if you haven't. There's plenty more where this came from. And I'll see you next time. Bye.